In this video, we're going to do find unique number coding challenge. So what we're given is an array of numbers, and all the numbers are duplicated. So we can see that number 3 is duplicated, 2 as well, but 5 is not duplicated. So we have one number that's not duplicated, the rest have duplicates. And what we need to return from this function is the only unique number, which in this case is 5. So how to solve this? So one way of solving this problem is we could allocate new hash map, which will be our counter, and we iterate over all the numbers inside the array. So we start, let's say we start at index 0, so our count is 1, right? And we move forward, and then it's 2, so and we have 2 2s all the way to only one number 5, right? And when we're done, we iterate over our hash table, and when we find a number that has a count of 1, we just return the number. So this would have of n runtime, right? This would be time, and space would also be O of n, right? So this would be one way of solving this. Another way would be to first sort the numbers, right? So we would sort all the numbers, and then what we'll do, we just iterate and look the next number. If the next number is the same, it's cool, we can just move 2 places and then look again. If we're like at the end or the next number is not the same, we just return the next number, right? So for this solution, our runtime would be actually n log n. N is the number of elements inside the array, and n log n is because we sorted the array, and for space it's O of 1. So this would be a valid solution, but there's actually one more way of solving this problem, which has more optimal runtime, and it's using Xor Operator. So you probably know or not. If not, let's just quickly recap what Xor does. So if we have, let's say, bits, we're looking at bits now. If we have bit 0 and we XOR it with 0, or we have 1 and XOR it with 1, both of those guys evaluate to 0. But if we have on either side 1 0, this evaluates to, this is 1, evaluates to 1, right? So this is our Xor operator. Cool. Okay, and now how can we use this? So if we have results variable here, let's say that we start with results, which is 0, which represents, let's say, all the bits are zeros. Okay, and if we let's say XOR this current results variable with 2, which is just this, and this becomes 1 and 0 is 1, it becomes 2, right? But then if we XOR this number with 5, let's move the 5 down. So 5 is just, so we have 1 bit of 4, 1 bit here, all the rest is zeros. So we have 1, 1, 1, and 0. But if we then again XOR this current results variable with 5, these numbers, because we use XOR, will cancel each other out, and we can see this in this example, right? So we have 5, we XOR this number, so 1 1 becomes 0, 1 0 becomes 1, and 1 1 becomes 0 again, right? And we can see this. We can see that we're back at having 2 again, right? So this is our solution. Let's talk about runtime. So for time, we would say that it's O of n. We're only going through array once, and for space, we're not allocating any additional space, so it's constant. We only have one variable that is has a value of just an integer, right? So let's look at how this solution might look like in code. So let's have an array of numbers 3, 3, 2, 2, 4, 4, 5. Print find unique. Cool. First thing we need to do is just have a results variable, and then for number in array, we just XOR the current results variable with number, and believe it or not, we're done. Let's just run this. We have 5, right? The solution is quite simple. If you understand how to use Xor Operator, you can solve this with optimal time space complexity. Yeah, so that's it for this one, and see you guys till next time. Bye.